Welcome, everybody. I'm going to start this evening's proceedings. My name is Ian Firth. I'm the chairman of the British Group of IABSE, and it's with great pleasure that I welcome you all. The numbers are growing all the time. We've got a good turnout for this evening's session. Welcome. We have a lecture to come from Margaret Cooke, who's this year's Milne Medal winner, and I will introduce her and the medal shortly. But we've also got just a couple of other things before we get to that. We don't have the usual sort of safety notice or other thing. You all hopefully know where you're sitting and what the fire evacuation procedures are. I don't need to go through that. Also on the screen you've got David Knight, who's the Vice Chairman of the British Group. And I'm going to hand over to him because we have, in advance of Margaret's talk, we're going to award this year's Nethercott Prize. And I'll leave it to David to announce what that means and who is the winner. So David, please.
Thank you, Ian. Yes, the Nethercott Prize is something that we have instigated over the last few years. It's awarded annually to an early career architect, engineer or designer, generally expected to be under 35, but that's a loose guide and based in the UK. And the award is in recognition of the quality of a written paper submitted for judging. And what we're really looking for in those papers is the quality of storytelling and reflective writing about projects and work that they've done. We're very pleased that we had a shortlist of 2 this year. We had a paper from Hazel Needham of Expedition entitled Design for Manufacture, and a paper from Craig Buchanan of Imperial College entitled Delivering the MX 3D Bridge. Both papers are available on the website iabse.org.uk to read. The judges read through both and we're delighted by both, so do take a look. I'm really pleased to announce that we've decided to award the Nethercott Prize this year to Hazel Needham of Expedition, and she will be a recipient of a contribution of £400 towards participation and travel to an upcoming international event. I'll get in touch with Hazel separately. I hope she's on the call, yeah, congratulations to her.
Oh yes, congratulations to Hazel. Don't all clap because it would get very noisy, but Hazel, well done indeed. Very good. Thank you, David. Just a brief word about IABSE. For those of you who are not sure about what this organisation is, it stands for the International Association for Bridge and Structural Engineering. And it is what it says on the tin. It's international, and we deal with all kinds of structures, all materials, anything that is basically structural, and it is international. And I can see even now, looking at the list of participants, a number of people who are joining us from overseas. So particular welcome to you. That's the beauty of doing things online. We can do it that way. We are the British Group, and the International Association is formed from a number of national groups. And we, the British Group, like to think, of course, that we're the best. Of course we are. We hold all sorts of events and give all sorts of prizes and awards. You just heard about one of them, the Nethercott Prize. And tonight we're here to celebrate the Milne Medal, which this year has been awarded to Margaret Cooke. The Milne Medal is awarded to an individual engineer, an individual structural engineer who has demonstrated expertise in structural design. This is what we're looking for. We're looking for somebody who really has that design expertise and has over some years demonstrated design leadership and expertise. So that is, it's awarded in the name of Bob Milne, who for many years was the Honorary Secretary of the British Group. When he died, it was decided then, some years ago now, to award a medal in his name once a year to an individual structural designer. The list of the recipients over the years is on our website. It's quite an interesting list to look at. It's a sort of roll call of the great, and I'm embarrassing Margaret now, not sparing her blushes. But it's a great pleasure for us to be able to award it to Margaret. If we were in person at the institution's headquarters, I would at this point hand her a medal, but by the miracle of post, it has actually arrived, and she can wave it at us just so that you can see that it really does exist. There it is. the Milne Medal with her name on it. Many congratulations to Margaret. Margaret is Director of Integral Engineering, one of the founding directors of Integral Engineering, and she's been working over 30 years on existing buildings, many of them listed, many of them, most of them, I'm sure, are those buildings which needed to be conserved. And very often the engineering skill is about realizing and showing how it's not necessary to knock it down and rebuild it. We'll be hearing about that. She's passionate about minimum intervention, and in this day and age, when we're having all of us to minimize our impact on the planet, minimizing the carbon content of what we do, that is absolutely the way we are going to have to go. So this is a very timely award that in the current climate, when we're all talking about the climate and carbon, and while things are going on in Glasgow and all of the rest, we're delighted, particularly Margaret, to award this medal to you this year. And so without further ado, I'm going to ask Margaret to switch on her microphone, me turn mine off, and let's hear Margaret's Milne Medal lecture. Hopefully when we share the screen, it'll all work seamlessly. Over to you, Margaret.
Wonderful, thank you, Ian, and many congratulations to Hazel. That's an amazing thing to do so early in your career, so well done. And many thanks to IABSE for this honour. I'm still slightly stunned and humbled by being given this medal when I look at the engineers who've preceded me, and no doubt those who will follow. It does, however, as Ian says, feel like a timely moment to celebrate those of us who practice the art of doing as little as possible, which sounds flippant, but of course it's not. If we're going to meet our carbon targets, anyone in this audience tonight who is under 35 will spend more of their professional lives reusing existing buildings than building new. And those of us who are older will need to spend the latter part of our careers advocating to clients for reuse rather than new build. And I would say that traditionally conservation and reuse has been less celebrated. It's harder to teach, it's harder to explain. And of course, when the before photograph and the after photograph look exactly the same, it can be hard to explain to a client why your services have been worth paying for. And it relies entirely on a good story rather than a good image. So I've been asked to talk for about 45 minutes, and we'll hopefully have some time for Q&A. And the things I want to talk about are a few of the challenges that I and my team have faced over the years and how we solved them. I want to show you how we judge when we need to repair and when we can leave things alone. I want to show that actually finding the solution is often the easy bit. The difficulty is in defining the problem. And I am, of course, very conscious that this is a very broad audience. So some of you are my teachers and mentors, the people I turn to for advice when things are looking peculiar. Others work almost exclusively in a world of new buildings, and this reuse thing is a bit of a mystery. So bear with me as I navigate the balance. So I wanted to start by talking a bit more broadly about why I think reuse is exciting. So let me share some slides with you. If I can find the right one, that one. I'm hoping you can now see that. So what got me into reuse projects was the challenge of it and the mystery. It's forensic science in building form, or it's a jigsaw puzzle which may or may not fit together and where some of the bits might be missing. You've no idea what you're going to find when you start. Is it going to be robust or fragile? Is it going to be logical in its layout, made of beautiful materials by craftsmen at the top of their game? Or was it once good, but it's been so neglected or so adapted that it's now a very different building? There is the challenge of working with materials whose properties you don't know. This roof, in fact, is very early steel, but it could equally have been wrought iron. It's right on the cusp of that change between the two materials. And how can you prove that a truss this slender stands up? I can tell you it can't if you apply loads dictated by modern codes, and yet clearly it does. So here I have a material whose properties I don't know, that theoretically doesn't stand up if I apply modern wind and snow loading to it. Some areas are clearly corroded, yet others are perfect. It's one of the most beautiful spaces I've ever walked into. I know that if we build a new version of the same thing, we'll never be able to afford the fine craftsmanship that went into these original trusses. I have an architect asking if they can replace the 4mm thick glass with double glazed units, and I need to work out whether the roof is clinging on by its fingernails, it's survived, but only just, or whether it has sufficient integrity with a bit of TLC to give another 100 years of service. Essentially, how do we know when we should do nothing, even if the calcs tell you the thing you're looking at is quite fragile? Or how do you know when public safety is actually a concern and you should be shouting, even if the thing you're looking at has stood up perfectly well for several hundred years? Oh, sorry, I've gone too far. Oh, there we go. It's the excitement of discovery. So even now, when I've been grubbing around under floorboards for nigh on 30 years, not quite, Ian, it's still exciting to find out about a building. So my colleague Prema and I visited a site a couple of weeks ago. The lovely maintenance team had raised some of the floor for us so that we could see and measure a beam that we knew was there because it downstands into the room below. And we were faced with this rather unpromising pile of dust and joist tops and apparently no beam, until we went up close and did a bit of dusting and revealed the top of a steel flitch sandwiched between two chunky timber sections. The beam was there, but hidden in the dust and the pugging layer and the services. And it runs under the floor like this. It's a connection with our predecessors. We can use their drawings to get an idea of intention at least, even though there are clearly never any guarantees that the building was built that way, or indeed that it is still that way 40, 80, 280 years on. This work forces really good observation skills. There's no point being able to do brilliant mathematics if the materials you're working with are flawed. You need to know about a wider group of materials than we get taught about in our standard university curriculum. Cast iron, wrought iron, vaulted masonry, timber, poor quality early concrete. You need to understand that the failure mode of a cast iron beam is completely different to the failure mode of a timber beam. And that difference will inform your attitude to risk in those different situations. You need to hone such a wide range of engineering skills. You need to be a solid mathematician, but you also need to be ready to look closely and carefully at what's actually in front of you. To be ready to use all of your senses, smell and feel, as well as sight, to tell you about the building that you're in. You need to be able to research the history and use of the materials you're faced with. You need to understand the history of the building itself, what it was built for, how it developed over time, whether it's had any major refurbishments, and therefore what techniques and materials might be associated with that. And you need to be able to put yourself in the shoes of the person who built it. What were they trying to achieve, and did it do what was intended? It's a world in which you have to expect the unexpected. So this is Toddington Manor, high Victorian Gothic in Gloucestershire, Grade 1 listed, built in the early to mid 1800s, local stone and timber and some cast iron. And these are the roofs. They look, if a little shallow, perfectly normal and regular, and indeed they turned out to be made of really lovely high quality oak. And when we opened them up, they had a perfectly sensible arrangement of trusses and purlins. So this is it on plan. But when you look in elevation at the trusses, they are completely mad. Each one is different from the next for no apparent reason whatsoever. It's like the carpenters were having a competition to see how many different ways they could span a space. What it isn't is guesswork and instinct. Although some of the things I show you, I will show you what started from an instinct, the instinct comes from experience and it's supported by science. So we observe, we test, we do calculations which we know are flawed and yet give us a feel for what we may have in front of us. We use technology as it becomes available, especially in measuring and monitoring. It's a world where you have to be a bit clever in how you test things. So this is a building we're working on at the moment in Wales. It's the Festiniog Steam Railway. And the mezzanine floor structure in this building is formed not from beams, but from sections of rail, because of course, that's what they have to hand. And it has some pretty weird connection details. So the column, the primary beam, the secondary beam, and the corbel on which the beams all sit are all sections of rail. And this is what passes for normal in my house. The spare piece of rail sitting on my dining room table, waiting for me to send it off for laboratory testing if we need to. And we also test on site. So this is a set of trusses at Durham Park where the bottom section of each one needed to be replaced. But it's impossible to calculate whether these sorts of traditional carpentered splice joints have sufficient capacity. So here, the contractor simply load tested each one as they finished so that we knew each one was okay. There are undoubtedly moments when it all feels a bit like this. And while it's not guesswork, it does force you to use engineering judgment. There are no codes to tell you whether your slightly rotten beam end is still well within capacity or right on the edge of viability. You have to be ready to consider how something might fail and therefore whether what remains is sufficient with sufficient safety factor. You have to question whether you need to repair or strengthen or whether you can just leave something alone. So I'm going to show you 3 buildings from the many we've worked on over the years, and they show 3 different approaches. One is fairly typical of the interventions we make. It's visually unobtrusive, but very necessary to support the ongoing life of the building. A second has 2 examples where we could have done a lot more work, but managed to monitor and negotiate our way out of doing anything. And a third one is a quick one, which is a much more modern example. And as always, in these kinds of projects, the skill lies not so much in designing the solution, often that bit is relatively easy. The issue lies in defining the problem and agreeing the constraints. So on to some case studies. This is Boston Manor. It's grade 1 listed, it's in West London. The main core of the building dates from 1662, 1663, which is these 2 gables here, this block here. The third gable on the left was added in 1671, and the 2-storey extension, which here is hidden behind the trees, was built sometime in the mid-1700s. And it's an amazing building. Inside, it has some really lovely 17th century plaster ceilings, and it's really very elegant. But it has had a bit of a ragged history. The poor building was bombed in the Second World War. At that time as well, it was a school. So it was a school between about 1940 and 1961, and it was last comprehensively restored in 1963. It's owned by the London Borough of Hounslow, and it's been underused for too long. So in 2017, they got funding from their own coffers and from the National Lottery Fund for Heritage to renovate the building and bring it back into use. And the plan is to open the building up again, sometimes as a museum to talk about the building itself, but most often as a place to meet. So there's a cafe downstairs, which serves as a connection to Boston Manor Park. There's rooms in the main part of the building, which will be used for meetings and events. And the 2-storey extension will be rented out to local businesses. And as ever in these buildings, we did a lot of investigation and opening up to find out what we were dealing with. And here, the history of the building is invaluable. Knowing this, knowing and understanding the history is invaluable. It's not just social interest, it's technical interest. For example, we might expect differing details in the 1963 parts of the main house, the pink bits, than we have in the 1967 bit, the green bits. The 1623 bits and the 1671 bits. And indeed, we find we do indeed have a cellar under the later section, but not the earlier. And there are straight joints in the brickwork, and the room shapes and the structure is different. So knowing the history helps us to know where we're likely to find different structural configurations and potentially different quality in the construction. So Chris, my colleague Chris, and I did some extremely careful opening up. This was one of those buildings where we needed listed building consent even to lift a floorboard. And we worked out floor capacities, we looked at deflections, we worked out where we needed to do little bits of strengthening to a very few primary beams to increase capacity just enough to make the business case work, which I'll come back to in a moment. And it's a fine balance between wanting to do as little as possible while still giving the building a viable future. It might just be worth noting that the flitch detail in the top here is one that we use a lot in listed buildings. Essentially, you cut a slot into a timber beam and slide a piece of steel in to provide stiffness and strength. It's quite a skilled job, but we use it because we want to retain the detail of the joist connection to the primary beam. If it were an unlisted building or a more ordinary beam, we could achieve the same outcome with something simpler like a channel or an angle section on either side. So in order to know which floors we're going to strengthen and which we'll leave alone, we produce these diagrams of load capacity. So on the left is the existing situation, and the red, amber, green coding relates to the live load capacity. So red is less than 0.75 kilonewtons a square metre, so less than half of a normal domestic load capacity, whereas the green is 2.25 kilonewtons a square metre. It's nearing a full office loading by modern standards. So given that the client was going to be able to manage the building very tightly and the use was relatively light, I mean, a meeting in one of these rooms might give a live load of less than a kilonewton a square metre, we didn't think it was appropriate to bring the whole building up to modern office standards with all the intervention that that would have meant. In discussion with the client and the architect, however, we chose to strengthen to reach between 1.5 and 2.25 kilonewtons a metre squared, which allows 2 middle-sized people across every square metre of the floor plate, which is surely more than enough. So on the right-hand side, you can see the proposed situation where all the spaces on the first and second floor have become either yellow or green. We use point cloud surveys to create contour maps of the brickwork faces to see if, so that the brickwork is bulging, and we wanted to see if it got any worse since it was last measured by Hounslow in 2002. And move that on. So, and we did a lot of timber repairs in the extension building because that had suffered enormously from water ingress. But the thing I particularly want to talk about is the main staircase, that one here. Because this is a great example of the importance of defining constraints and how a solution which seems really simple is the result of some very careful analysis and negotiation. The stair is very important historically. It dates from 1623. It's the oldest part of the building, and it's decorated with some really very fine and very rare hand-painted wallpaper from the 1750s. Any work on the stairs, therefore, needs to be really careful of the paper and also needed to respect the original structure of the staircase itself. So the staircase is surrounded by masonry walls, so right round here, and this one is slightly lighter wall. And if we remove the walls, we can see that this is the staircase with the floor structures around it, and the stair was in a bit of trouble. There was a significant slope across each tread of about 100 millimetres, particularly in the section from first floor to second floor, and it was very lively. When walking up and down, you could actually see it deflecting. To define the engineering constraints, we needed to understand how the stair was structured, and it was fairly clear that the deflection was a result of a complex load transfer path, with loads from the second floor being transferred through 2-quarter landings to the first floor structure. So the 2-quarter landings to take particular note of are this lower one and this upper one. So to know more, we wanted to do some opening up work, and we could see that the underside of the stair had been replaced at some point in the past, which gave us a way in without damaging original finishes. And some initial gentle opening up revealed modern plasterboard, which meant we could uncover all of the structure, which certainly would not have been possible if we'd had original intact finishes. Further opening up showed that the lower quarter landing had been replaced entirely with relatively modern joists, yet it still wasn't stiff enough to stop the landing and thus the stair flights from rotating. So we had an idea about how to stiffen the staircase or stiffen the lower landing, replacing the lower landing with a new arrangement of a cross member spanning between the walls and a cantilevering member to pick up the stair edge. It's a slightly unusual arrangement, but it should work. So that dealt with the lower landing in principle at least, but the upper landing couldn't be treated the same way because the original landing timber was still in place, and we didn't want to put structure below because it would be visible, which would be a shame. However, here we had the advantage of a wall, which went from the stringer right to the ceiling, through the second floor and to a truss above, which we could call into action. And we thought we could potentially slide in a hanger of some sort to support the corner of the landing. Initial calculations showed that it would be very hard to justify the staircase if we simply tried to put a standard staircase load on it. Yet this stair is a primary escape route and the building was going to be far more heavily used than it had been for many years. So we couldn't just say it's survived so far, it'll be fine. Going back to our floor capacity diagrams, we could see that the rooms the stair served couldn't be justified for normal standard live loading. There was no way from a conservation point of view that we could justify the strengthening work which would be necessary. So we were already in a situation where our client was going to have to manage the building carefully to ensure the rooms weren't overloaded. So there was no point trying to strengthen the staircase to carry a theoretical load it would never have to carry. So there followed some fairly lengthy negotiations with the fire engineer, building control, the client, working together to ensure that room use, fire escape requirements, stair load requirements, and the business case for room bookings were all aligned. And make sure that no one element hugely outweighed another, or indeed that no one element was the primary constraint. So once we had a figure to work to for the maximum number of people on the staircase at any one time, we could turn our attention back to the detailed design of the interventions. So the hanger had to be designed to limit extension, and we had to work out how to fix it to the newel post and the stringers and how to get sufficient tension into the system. We also had to work out whether the trusses above could carry the additional load. And the poor contractor had to try and get the hanger in without damaging the wallpaper. So the photograph on the left shows the hanger in position, and the photograph on the right shows the wallpaper just on the other side of the wall. On the other side of these laths here is this incredible wallpaper. So it was a bit of a task. The lower landing, going back to that lower landing, where we have this idea of how we were going to do it, the lower landing was incredibly shallow. So the original design of crossed members had to be packed down into a single plane, which meant that the whole thing had to be prefabricated off-site so that all the connections could be fully welded. And that meant the contractor had a bit of a job getting it into position, but they managed beautifully, and the new steelwork is completely hidden in the depth of the landing. So I said at the beginning that this solution was an example of the importance of defining constraints, and I hope what's clear is that the analysis is not a mathematical analysis, although that obviously is one of the tools, but actually designing the solution is simply the end point of pulling together a lot of different constraints, technical structural constraints certainly, but also conservation constraints, buildability, and a negotiation requiring an understanding of the business case as well as the engineering detail. So the lesson for me here is that the difficulty is not so much in designing the solution, but in making sure we were answering the right question. Did it need strengthening? Yes. How much strength to add? A much harder question to answer, but definitely not 4 kilonewtons a square metre as the normal loading code might stipulate. So on to case study number 2. This is Middleport Pottery in Stoke-on-Trent, built in 1888, and it was known as the model pottery because it was absolutely designed and built around the process of making, decorating and firing stoneware. It was an efficient modern factory. And it was also built around some of the Quaker principles of creating decent working space for the employees. So it's an amazing set of buildings. And in 2014, when our client, the Prince's Regeneration Trust, bought the site, the pottery was a thriving business. There was nothing wrong with it economically, except that they no longer needed as much space as they had. So they were struggling to maintain the sheer number of listed buildings. And what's special about this place is that the pottery is still being made here in the traditional way. So apart from the firing process, which has moved on from effectively making a fire in a big brick thermos flask to build up the heat and keep it there, it's now done by electrics. The process would be completely recognisable to someone from 100 years ago. And so just for interest, this is what they make. They make cups and jugs and plates and all sorts of things. And they decorate it in a unique process called tissue printing, where these incredibly skilled ladies, and they are all ladies, wrap the intricate shapes in tissue paper, and somehow they do it without making visible creases in the pattern. It's extraordinary. And all the while they are chatting at a rate of knots without even looking at their hands. It's absolutely amazing to watch. So the plan was to consolidate the pottery into a more compact area of the site and wrap around them the things that the Prince's Regeneration Trust do best. So new galleries, a visitor centre, a cafe, and most importantly, incubator units for new businesses to support economic sustainability for a wider population than just the pottery itself. So we were looking at change of use in many areas, and we were looking to refurbish the whole factory to a reasonable standard, but all within the context of a grade 2 star listing and a pretty tight budget. And this is what we were faced with on our early visits. We were making an awful lot of judgment calls early on in terms of guessing at how much needed to be done to support initial early cost estimates and the initial space planning ideas. So we were making really broad judgments like, allow for 30% of the rafters to be replaced in this building. Assume that floor is probably all right, but this one might need stiffening. You know, talking to the caretakers, it became clear that the drains were totally blocked by clay particles and would need cleaning at best and replacing at worst. And there was considerable concern about asbestos contamination throughout all of the buildings. So I want to show you 2 specific areas in this building where we chose not to intervene for different reasons. This is the first space. And a previous engineer had been asked to look at emergency works on the site and had picked up this crack right along the top of the wall. Not unreasonably, he'd suggested that this might be due to the roof spreading, pushing the brickwork out and creating the cracking visible on the inside. So something like this. And if that was the case, then the solution would be to remove the tiles and board the whole roof out with plywood to create a stiff diaphragm. But before that work was done, we were appointed to do the main project. And we had the privilege, we weren't appointed just to do emergency works, we were appointed knowing that we were going to be messing around on this site for a few years. So we were able to take a less conservative approach and spend a lot more time looking and contemplating. And what occurred to me was that while there was clearly movement on the inside face of the wall, it wasn't reflected on the outside face. That appeared to be absolutely straight and vertical with no movement at all. And we wondered if there was a different cause, and we managed to get some opening up works done. And when we did that, this is what was revealed. So the rafter appeared to be sitting happily on its wall plate on the outside face of the wall, and the brick on the inside face had slightly unusually been built right up to the underside of the boarding. So there probably had been a bit of movement in the early days, as you would expect as any roof settles and takes up the load, but nothing on the outside indicated that the movement was ongoing. So slightly with my heart in my mouth, I said we shouldn't do the work right away. We should keep the money for repair in the budget, but in the meantime, monitor to see if the situation changed. So for 2 or 3 years, every time I went to site, I anxiously looked at the wall to see if it had shifted at all. And in the end, happily, there was no further movement, and we never did end up having to ply that roof out. So this is the space as it is now after the work is complete. And the lesson for me here is that there is no substitute for time. If we're not given time to get to know buildings and observe them, then we have no choice but to take a conservative approach. After all, it's your professional reputation on the line at best, or a building in a state of collapse at worst, if you get it wrong. With time and observation, we can save material and programme and expense, but our clients do need to give us that time, because believe me, it's much, much harder to say do nothing than it is to say do something. At least if you've done something, your clients feel you've earned your money somehow, which is completely mad, really, but also entirely understandable. This was a much scarier one. This incredible space is where they store all the moulds for the last 100 years or so. So when they make something which is an intricate shape, like a Toby jug or a teapot or a little cow-shaped jug like this chap here on the right, they make a mould for it. And they pour slip clay in, which is basically thinned down clay. They pour it into the mould, let it dry for the right amount of time, pour the remaining wet slip back out again, and then pull the mould apart to reveal the shape inside. It's really clever. And some of the moulds are in use all of the time, but others are only used for short runs. And when they're finished with, they're never thrown away. So this is effectively the pottery archive. And where do you put things you no longer need day to day but don't want to throw out? You put them in the attic, of course. So people access this space all of the time. The Prince of Wales had visited only the week before us. And I'd been in the space before with the rest of the design team and the client to understand what the space was and how it was used and what the client wanted to do with it. But on this occasion, my colleague Kim and I went alone with our engineering heads on. As we walked down between these bookshelves full of moulds, it just didn't feel right. It didn't respond as it should. Something in the floor felt really tight. It was about vibration. It was like walking on a trampoline. And looking down, we realised that the bookshelves had punched through 2 layers of floorboards. So we took some measurements on beams and spans, and we weighed a representative sample of moulds. And on the way home on the train, we did some pretty rapid calculations. And the structure of this building is absolutely typical of industrial buildings from the late 1800s. So we've got masonry walls and timber floors spanning between wrought iron beams, and the beams span wall to wall, supported at the midpoint on a cast iron column. The calculations, horrifyingly, but perhaps not surprisingly, showed that the cast iron columns were okay, as were the masonry walls, but the wrought iron beams and the timber joists were in trouble. And the primary beams were 4 times overstressed. So we slept on it, always a good idea. And the next day I wrote to the client to say, you need to stop using this space. You need to get some props under the primary beams immediately. And we need to make a plan for how on earth to get the moulds out without the shelves falling on top of someone. So that dealt with the immediate safety issue to an extent at least. But we still had the issue of what to do in the longer term, because this space was supposed to be a key part of the visitor experience. And there were historical and emotional reasons for wanting to keep it in its original space. And I'm normally pretty relaxed about calculations that tell you something ought to have fallen over when clearly it hasn't. It usually means your assumptions are wrong. But even I get worried when something is that far over any normal limit. It might be standing up, but possibly only just. And this really did feel like a clinging on by its fingernails moment. So how do we tackle this? Can we do nothing? Is that an option? We thought not. We thought the stresses were far too high to take that risk. The straightforward answer was to try and make it right somehow, to strengthen the structure to make it work. So we considered putting in additional props to the primary beams, as we'd done with the emergency propping, but that was incredibly disruptive to the floors below. So we considered putting additional beams across the space in between the primary beams, which would reduce the load on the primary beam and reduce the joist span by half. It was probably less disruptive, but it was still costly and difficult to achieve in terms of getting long beams into a tight space. So, having convinced ourselves there wasn't an easy strengthening answer, we turned the question the other way around. Why did the archive want to be on the top floor? It's a mad place to put any heavy storage. Social history says the molds go in the attic, but every other driver says put them on the ground floor. For example, availability for cataloguing, visitor access for people who want to see the collection. If they stayed on the top floor, we'd have had to get lift access up there. By putting them on the ground floor, we would avoid the need for a lift, as well as the need for structural strengthening. So here is the before and after shot. The old one is on the left, the new archive is on the right. And it looks much the same as the old one, but it is significantly safer and more accessible and a lot cheaper environmentally and financially. So there are 3 lessons for me here. One is the importance of quiet time when you're getting to know a building. It's really important to know your client and know their aspirations, but it is equally important to spend time away from the rest of the team so you can really concentrate on your own expertise, because engineers see things in a different way. And it wasn't until we had time to relax and observe properly that Kim and I saw and felt the issue. The importance of asking the right questions. Rather than heading straight for the how, ask why. We had numerous options for strengthening, but actually, when viewed in the round, the answer that arose out of a technical and economic necessity, moving the archive rather than strengthening the floor, also answered a series of other questions about accessibility that was starting to look hard to solve. And the importance of bringing your client with you. In both cases that I've shown you on this project, we were able to explain clearly what our strategy was and give them the options available. And ultimately, the choices were our clients' choices. We provided the technical options and gave a balanced critique of each one so that they were in a position to make the decision that was best for them. So, case study number 3. This is the quick one, and this is Trowbridge County Hall. So it has a very fine 1930s building, which houses all the normal functions of a county hall. It has a debating chamber, it has some lovely meeting rooms with high ceilings, plenty of natural light. It's a very handsome building, and although it's not listed, it clearly ought to be. So we treated it as such. Tacked onto it is a 1970s building, and it's rather less lovely. It's concrete framed, and it has all the typical issues of buildings of that era. It has deep floor plates, poor floor to ceiling heights, leading to minimal natural light. It's poorly insulated, and almost inevitably the connection between the 2 buildings, the 1970s and the 1933 building, that was really poor. And it had numerous level changes, which made it impossible to navigate for anyone with mobility issues. So on plan, we had this situation. The 1930s building is in green, the 1970s building is in blue, and there is a wind-blown courtyard between the 2 buildings that was rarely used as it was in shadow so much of the time. And that's what it looked like. And so as a team, we looked really carefully at our options. We considered everything from complete demolition of the 1970s building and new build, to putting a hole in the middle like a donut to get natural light into the heart of the space, through to keeping and refurbishing the entire building. And to cut a long story short, it was absolutely impossible to justify in carbon terms demolishing the building structure, even when you took into account the opportunities created by replacing it with something in, say, timber and steel with perfect insulation, passive ventilation, looked at over many years of life, it wasn't possible to make the case for total demolition. There was simply too much carbon embodied in the concrete frame. So we took the save and adapt approach. We took out the drop ceilings to expose the concrete soffits. The architects insulated the walls and roof. They put meeting rooms, which needed mechanical ventilation anyway, in the centre of the floor plate, so in here, where the lack of light for people for limited periods wasn't an issue, and indeed, when doing presentations, could be positively beneficial. And we did limited but high value structural alterations to open up spaces, especially at the ground floor level. The circulation issues were sorted with the only section of demolition and rebuild in the project. The building at the front was demolished and replaced with a lightweight steel and glass entrance, which not only creates a more obvious welcome to visitors, but also houses stairs and lifts, allowing people to move relatively easily between the 1930s and the 1970s buildings. And finally, the courtyard was over-roofed with a light steel and trusses and ETFA pillows to create a cafe and a welcome space. So this is the over-roofed courtyard looking towards the new entrance building with the 1930s building on the left. And these are the new offices in the 1970s building, which have now lost the drop ceilings. And while the architecture of the 1970s building may not be entirely to your taste, what I like about this case study is that it demonstrates the same approach we use in historic buildings. And that approach is equally applicable to much less glamorous buildings. The same need to spend time understanding what you're looking at and what you're working with, the time taken to think through the options, the same regard for the fabric, no matter what its historic merit, purely because it's already there and already functioning. And the project was highly successful. It's not only a welcoming and well-loved building for users, it also performs really well technically, and it saved the council a great deal of money, not only in the build, but also in the running costs. And to take the carbon counting piece just one step further, I want to give you some figures. So the better end of our new build projects sit in the range of between 200 and 300 kilograms of carbon per square metre. So 200 would be, say, a wholly timber building, and 250 might be a steel timber hybrid, and 300 might be a steel frame with precast concrete floors. Trowbridge County Hall, which was quite an intrusive refurbishment with some demolition and new build, came out at 100 kilograms of carbon per metre squared, so about half the carbon cost of our really very best new builds. Middleport Pottery, which had practically nothing new at all except improved circulation spaces and some careful repair, has a carbon footprint of just 18 kilograms of carbon per metre squared, so a tenth of our very best new build projects. And if we're to reach zero carbon by 2050, we don't have an option. We all need to get really good at this thrifty way of doing structural design. We need to be able to look at what we have already, analyse its strengths and weaknesses, and convey that information to our architects and clients. And we need to advocate for reuse. And that means a change of mindset, not only for us, but also for the teams we work with. We need to be prepared to be much more flexible in our approach. So, like Middleport, we need to be ready to change our ideas about which spaces are used for which purposes and not lock our ideas down before we've had time to get to know the building. And like Trowbridge, we need to be ready to accept that a building may not match our current idea of perfect, but that with clever space planning, it can be made not only good enough, but exceptional. Oh, we're nearly there. So I hope that's given you an insight into the world of reuse, the kind of technologies we use, the kind of thought processes we go through. And it's important to say that nothing we ever do is the work of a single person. Obviously, my incredible team at Integral and the mentors from other places I've worked, but also colleagues from other practices, because engineers are the most incredible community of understated, knowledgeable, generous people. And if we're to use as little as possible, if we're to do our bit towards reducing the use of carbon heavy materials, we need to be able to draw on the experience of others. None of us can know all the things about everything, and we need to regularly sense check what we're doing. And so I come back to my initial question: how do we explain to other people what we've done, why we've done it, and how it's added value? And I think it's about storytelling and about bringing your clients along with you. It's a challenge when the before and after photographs are the same, but anyone who's been on the journey with you knows what you've done and what a difference it makes. Our client at Boston Manor knows that the staircase that used to be a bit frightening is no longer leany or creaky, and also that we've achieved that result with minimum intervention. The route to the right answer is often subtle and careful negotiation. So engineers need to be storytellers and negotiators, creatively thinking beyond the obvious answer to a more holistic view of how a client might use a building. And the wonderful new tool in our arsenal is a carbon story. We can finally put numbers around doing nothing, which allows a different measure of value. I often say to clients that we've really done our job right if we've made ourselves redundant by the end of stage 3. Building or changing absolutely nothing at all is surely the sign of real success. So perhaps one day our fees will be calculated on the basis of how little carbon we use rather than a percentage of construction cost. So that's me. Thank you very much for your time, and I'm going to hand you back to Ian.
Margaret, thank you so much. Wow, what an inspiring lecture. Thank you so much. Really, really excellent stuff, and something for us all to ponder. We're going to move into a time of Q&A and discussion now. And what I'd love to invite, I meant to say this at the beginning, please do put things in the Q&A that you see at the bottom of your screen. If you move your mouse, it'll come up, Q&A button. There's a couple of things in there already. Just write your questions in there, and we'll see how we go. Just while you're all thinking and sort of beginning to write some questions, I'm going to sort of kick us off and just sort of get us started. Incidentally, I noticed that Omar has got a hand up. I don't know whether that's it's been there for a while, so I don't, it's gone. All right. I'd rather do it by writing it in the Q&A, and we'll keep an eye on things. But we'll see how we go. But Margaret, I sort of wrote down various things, but one of the things you wrote down, I put in kind of letters in a box, and I sort of made it sort of big on my paper, but it's also big in my mind. There is no substitute for time. You know, this is so critical, isn't it? And it's not just in the world that you inhabit. I think it's in all of our worlds. But you seem to have found a way of talking to your clients and persuading your clients to allow you maybe that time, but allow you to do things which you know others perhaps are not brave enough to do, which is, as you've said, is often less, to do less. You know, talk to us a bit more about your way of approaching clients, because you've got to have enlightened clients. Your clients must be able to appreciate the point of waiting for you to do your investigations and come up with your solutions. How do you get your clients to get on side?
So I guess we're in a privileged position. We've worked at this very hard for 20 years. Sure. So we I mean, it's about trust, isn't it? Fundamentally, it's about trust, and it's also about reputation. So people now will come to us because we have a reputation for being able to do this thing. There's no doubt that being conservation accredited helps. Because people already come with an expectation of this sort of attitude that you might be bringing to a project. And I think we're also able to be quite straightforward. You know, even at the interview stage, you know, I will say to a client, you know, you need to invest. And one of my fellow directors, Claire, has a phrase. She says, design is an investment, not a cost. Yeah. And that's really, I think that's really clever.
That's very good.
And so we say that at interview, we'll say, you know, the thing is, if you want us to really help you here, you need to invest in our time very heavily up to stage 3, And if you do that, we will be able to save you an absolute fortune in construction. And so my phrase, which is Claire's equivalent, which is my equivalent to Claire's phrase, is that thinking time is cheap and doing time is expensive. So the thing we can do is, you know, an hour of my time is absolute peanuts compared to having 10 guys on site doing things.
Of course, yeah.
So it's that kind of, so it's those sorts of conversations, that we have very early, and to an extent, if I'm honest, we probably get rid of before we even start the clients who don't want to hear that message. We're in the privileged position now of being able not to pick and choose clients. I don't think anyone's ever quite in that position, but being able to be a bit more selective and say, actually, do you know, we're so far apart in our moral and, you know, in our attitudes to design, to building design, that, you know, you're not going to enjoy working with me and I'm not going to enjoy working with you.
Right.
So it is difficult, but I think, and actually I was having this discussion with another practice who were asking me almost this question, you know, how do you start to talk to clients? We were talking particularly about low carbon in that case, but how do you start to talk to clients, and particularly when clients don't want to know? And we were talking about the usefulness of being able to talk about carbon and being able to put numbers around it and those sorts of things, because if you talk carbon, you're also talking cost. I mean, it pretty quickly reflects construction costs. So these sorts of tools where we've now, through the I/E tool, the calculating tool, we've got something where, you know, if I carbon calculate a building, it's going to be the same as Bureau Hapold's carbon calculation, or the same as Arup's, or the same as Expeditions, or, you know, Price and Myers. We're you know, we can compare our buildings, whereas before we were.
That's right.
We're all kind of swimming around a little bit, weren't we? You know, all of us trying to do our own little version of the Bath University information, and now it's much better. So yeah, that's right.
Well, no, absolutely. I mean, it is challenging, but you've obviously seemed to have managed to get your clients to play ball. David, I'm going to ask you've been looking at these questions. There's lots of them coming in. So David, I'm going to ask you to sort of field questions or suggest.
Sure, happy to do that. Just for the audience watching on, I assume you can all see the questions that are coming up. There's an opportunity to vote on questions, which pushes them to the top of the list. So that's quite a good way of everybody agreeing which questions we should ask. And I'm going to start by the top of the list from Conall Doherty. Hi, Margaret. Thank you for a fascinating talk. A couple of questions. When determining the capacity of old timber beams, do you make any allowance for the increased strength that this denser, slow-grown timber is likely to offer compared to modern timber? And two, when installing the flitch plates, what measures are taken to avoid damage to the 17th century ceilings below as the beams were temporarily weakened?
Oh, okay. So the first one, just remind me what the first half of that question was again.
Higher strength for denser timber.
Old timber beams.
Yes. So yes, definitely, we definitely do that, because you're right, and you know, the timber anyway was higher quality, and B, you can it hardens with time as well, so they tend to get better with time as long as they've not been water damaged. So we absolutely do. When it becomes really critical, quite often we'll use timber testing, so micro drilling. And if you get somebody with a micro drill, which is a specialist piece of kit, then the density of the timber as you drill it will give you a measure of strength. So you can ask your timber specialist to tell you what they think the timber density is, and therefore give you some measure of strength. And absolutely, we take that into account. I mean, I guess the key thing is that obviously you're also looking for issues. So, you know, there's no point doing a great calculation on a lovely bit of timber if there's got a knot right in the middle of it. So you need to be a little bit careful, and you do need to make sure you keep observing. But again, you know, if you've got the privilege of having a timber specialist, they will also look at the timber. They will tell you what variety of timber it is. They will give you some advice on what grading you might allow for it, as well as the density. So yeah, there are folk out there who are absolutely timber specialists, and we do a certain amount ourselves, and we, you know, we'll do the initial calculations ourselves based on experience and knowledge. But if we think it's absolutely critical to get a better, clearer answer, then we'll go to a timber specialist. So that's part one. And then part two, the flitching, well, they're routing out the joint in the timber. I've never particularly worried about the loss of strength in that intervening period. Yeah, I've not really worried about it. I suppose you're doing it when you've got very few people on the floor, of course. So fundamentally, that's the thing. I mean, ultimately, once you've put the steel flitch in, then and you've bolted it all up, then it will be a lot stiffer. And you're usually talking about ceilings that haven't actually collapsed. So you're looking to limit. Certainly, in that Boston Manor example that I gave, we were looking as much to limit deflections under live load as we were to strengthen the floor as such. So we were looking to make sure the thing didn't bounce and create damage in the future as that room went back into full use. So it's as much a deflection limiter. So the sort of brief moment when it's got a slightly reduced strength, probably not really an issue.
Great. And next question is from Kevin. No surname, unfortunately. Good engineering decisions occasionally require brave decisions. In an increasing insurance cost environment with clients' legal advisors transferring increasing risk to design teams, do you only make non-conservative decisions when you know and trust the client, or does one fight the insurance risk transfer process at the beginning of the project?
I've always just tried to make the right technical decision, no matter what, and just ignored that, because I think if you worry too much about the insurance and the what ifs, then you're probably in deep trouble. All you can do is do the best job that you can do with all of your professional skill and care. And if if something goes horribly wrong, then you have to stand by skill and care, don't you? But I think I think it's almost the definition of professional. So yes, I've never worried too much about it, but I have, there are obviously situations when it gives you sleepless nights. There's no doubt about it. It's not easy to decide to do nothing. It's absolutely not easy to decide to do nothing. You do end up kind of having small moments when you flap and think, oh my goodness, did I do the right thing there?
Yeah.
And I quite like this question. Is there a building, this is from Robert Walton, is there a building that you haven't worked on that you would like to? All
of them. That's the problem, isn't it? You get greedy for it. Lots of them. I mean, ultimately, you fall in love with whichever building you're with at the moment, don't you? I just think, and there are some that I look back with more affection than others. So, Middleport would be one that I look back with enormous affection, but it's the building itself, but also the people and the people who work in it, and the craftsmanship of what they do, and the design team that we worked with. So, it tends to be more about the people as much as it is about the building that makes you think that was an amazing project. And I always think even the dullest projects always have some redeeming feature. There's always something in there. It's a really interesting client, or it's a fantastic contractor, or it's just a really interesting technical problem. There's always something which is interesting that you can take from a project, even the ones that are a bit grimmer than others. So yeah, but there are loads of buildings I'd love to work on. That's an impossible question.
I'll take Ian probably a couple more if you're happy with that.
Please carry on. There's lots coming. There's some good ones here.
Louise Lynch asks, for your team, how is learning gained or shared, especially with graduates who may not have the confidence to step away from the code?
So we'd never ask a graduate to step away from the code without backup. So we have quite a small team, and so there are 2 conservation accredited engineers on the team, so both Chris and I, but we also have others on the team who are learning their trade and getting very good at it, and we review really carefully. So yeah, we do. I mean, we say to clients that it's director-led all the way through, and it is. And I do quite often say to clients, if you don't like me, then don't employ me, because you'll still be seeing my boring face, at the point where you're on site and the sort of finishing, the finishing party, I'll still be there. So yeah, so we do. It's a difficult world, and it requires experience, and certainly, but I mean, having said that, you know, it's our graduates who are doing a lot of the calculations. So, you know, they're there doing sums. So I'll be going, but, you know, you sure why? Have you checked this? Have you looked at that? But it's, yeah, we're very hands-on.
Right, and then
I'm going to chip in, if I may, just to sort of pick up on that, and because I think this is so important. The kind of experienced head overseeing all the way through, and knowing when it's okay, indeed necessary, to go outside the sort of standard codified rules and things for whatever reason. And so often I think we find, I mean, my work has been characterized by a lot of that as well. But you often find clients or local authorities, you know, technical approval people, the building control, the people who they're really only interested in turning the handle of a standard code or whatever, and you need to find ways of persuading them and other members of the team as well. I mean, one thing I wanted to sort of ask you a little bit about was that sort of collaborative piece, about the fact that, you know, you're always working in teams, and you've got to persuade everybody else that you're going to be working outside the code. You know, what have you done? Is it just that sort of smiley face and says trust me, or you know, what's the secret, Margaret?
I think the secret is doing it very early.
Yeah.
So before things are decided. So for instance, that conversation that we had at Middleport Pottery about the archive, that was at stage 2, you know, so nobody, you know, we hadn't gone anywhere near listed building consent or planning permission, or, you know, we hadn't done major cost planning, you know, we were still very, very, very high level. And so, you know, if you're going to make a big change, like saying to somebody, I think your archive shouldn't be up there, it should be down there. Or if you're going to say, I think we shouldn't be trying to strengthen these floors to full office loading by modern standards, you know, you need to have that discussion really early on. We find it generally runs better when we can use approved inspectors rather than local authority inspectors. Not always. There are some fantastic building control folk out there, for local authority building control folk, but you do sort of get to know who's really good. So, you know, Birmingham listed building consent team and building control team are fabulous. So are the London ones. There are other places that I would say, I think we want an approved inspector there, because we know that they're difficult. We know that they find it, well, they, you know, fundamentally they're usually terribly overworked, and they don't have time to do anything other than box tick. So you're looking for someone who's got time to be a bit more thoughtful. So again, it's about the client investing. Fundamentally, isn't it? But doing it really early, so you're bringing them with you rather than just landing it on their plate and saying, oh, by the way, I've not really bothered with the codes here, is that all right? You know, we've had those conversations so that by the time it lands on their plates, they know exactly what they're going to get and why they're going to get it. It is, I'm going to say, it's also a lot easier if you're working with listed buildings. You know, listed buildings do a particular privileged part of the world where you can always sort of say, oh, well, you know, of course it is listed. If we did that, that would be terribly damaging. But we do the same with unlisted buildings. We take that same attitude and use it for unlisted buildings, but it does depend. So it depends. I did a project, golly, years and years ago now, sort of more than 20 years ago, for the blood service, and it was the most boring little concrete framed garage building, and they wanted to use it for storage. And the storage, so it was a building that you went in at ground floor level at one level, but it then the ground dropped away, so the ground floor became first floor at the on the other side of the building. So they wanted to use this ground floor level for storage, and you know, obviously we looked at the storage code and said, goodness, it needs to take sort of 15 kilonewtons a square metre or more. And there was no way that we could strengthen it for that. And we started looking at carbon fibre, and we started looking at all sorts. And then I said to them, what are you storing in here? And they said, cotton wool balls. Right. That's maybe not as much as 15 kilonewtons a square metre. So the answer there was to say to them, well, look, it can't be a storage facility as such. What we did, because it was a very ordinary, dull building, we just peppered the walls with great big signs that said, do not stack this building for more than this load. This building can only take this load. That is the equivalent of this. and just used signage to make sure that it was managed. So it's about, often if you're going to reduce the live loading, you need to manage the situation, and you need to be confident that your client is going to manage it.
Great, thank you so much for that. We must move on. David, take us another question.
Question from John Roberts. How does the increased performance requirements of facades impact on your structural work? There is increased insulation dimensions, weight, and perhaps also thermal break requirements. Often architects want to reclad. What are the biggest issues that you find for existing structure?
Ooh, so again, the thing is that in our office, a lot of the reuse projects on the sorts of buildings where you're going to reclad would be done by one of my other directors, Grant, who's particularly good at those sort of 1970s, 1960s, 70s, 80s buildings, and he's made a bit of a specialism of it. So I kind of want to pass to him to answer that question, because the thing with listed buildings, which is really my world, is that you rarely can clad the outside, because you'd immediately be changing the drip details or the look of the building or whatever. And again, you can rarely clad the inside. So usually our issues of if we're insulating and things like that, it tends to be inside the roof void, and we were more worried about making sure that airflow and things like that are right. So I've personally not really come across the major issues of facades, of taking off facade and putting it back on again. So I'm not the best person to answer that. Sorry.
Okay, and question from Jane Freary. I find it very interesting how you've managed to shift the dialogue to a much slower, considered, engineering-focused approach that clearly also requires the architect to compromise from their original vision. Is this achieved through existing good rapport, or do you often revert to an economic case for the change to get the client on board?
Both. Yeah, both. I mean, and again, so much of it is about good negotiating skills. It all comes down to being able to listen really well and say, okay, so tell me what you're trying to achieve, and I'll tell you what I'm trying to achieve, and let's have a coffee, and usually ideally a biscuit or several, and talk about it. And and it is, again, it's about creating that rapport and that trust, so that because you never want anybody to feel that you're just riding roughshod over them. You don't want to be the engineer who says, no, you can't do that, or you have to do it my way or it'll fall over. That's it's not a fun way to work. So we tend to work in a way which sort of says, well, look, we want to get the best out of this for you. Fundamentally, we all want the best thing for our clients, don't we? So and the best thing for our clients is going to be a combination of economically, it's got to be the best thing. It's got to be the right thing in terms of their use of the building. I mean, it's their building. It's not ours. We're only custodians. We're only, so we're trying to do the best thing for the environment, for sure, but also for their bottom line, and make sure that the building is eminently usable for them in the long term. So yeah, if they said, you've got to strengthen that floor because I absolutely have got to hold parties in it, then we would do that, because but they kind of, almost to an extent, they kind of have to make the case to me and sort of say, well, look, we really do, this is really important. Great. But yes, we do negotiate a lot, and we do ask a lot of questions. So there was one building where the client said, I really want to put the gymnasium on the first floor, and this was a really fragile listed building, and I just said, there is no way you're going to have to put that gym on the ground floor of the new build building next door. Don't even think about it. And bless it, he said, oh, I see the point, and moved it.
Which sort of leads, sorry David, I'm going to just chip in here, because I saw David Brett's question about dynamics, because I wanted to hear you deal with that. Often dynamic loading, dancing, moving in unison is a key design parameter. And how do your historic structures cope with it?
Well, I've got a bit of a thing about dynamics. So and actually it comes down to a material question. So yes, we are very mindful of dynamics, and particularly, so I suppose the times you'd worry about dynamics are when you've got something like a beautiful plaster ceiling underneath, then you'd want to be really careful. But also it's about materials. So for instance, I mean, a timber beam, as you know, will kind of, will bounce, and it will bounce quite unpleasantly a long time before it fails. Whereas a cast iron beam will just break. It will break like a biscuit. It'll be a brittle failure and you will have no warning whatsoever. So my attitude to risk, if I've got those two different materials, is very different. In the cast iron case, I'm a lot more risk averse because I know that my client will never have but they won't have the opportunity, they won't feel it before it goes. Whereas the timber, if someone's doing something bouncy on it, I do remember at university, the college hall used to spring. It was terrifying. So you've got those sorts of, you just have to think very carefully about the materials that you've got and what you're trying to limit. And it's only the same as dynamics in any other case, isn't it? It's the same as new build.
Sure.
We'll probably have one more question, if that's okay, Ian, and then
yes, it is absolutely. I mean, do fire away.
We have plenty, but I suspect we won't be able to answer them all. But there's a question from Stuart Marsh, which sort of brings us back to the major topic of the day. He asks the question about. He says he really likes the idea of being paid for keeping carbon as low as possible, as opposed to being paid a percentage of construction costs. He says it's a provocative statement, but do you think it's really possible? And how do we go about moving to that paradigm?
Oh, it's a bit utopian, isn't it? I have absolutely no idea. I'll throw it out there and we'll see if everyone else comes back with an answer. But no, I mean, I do think it is a real challenge, isn't it? And I remember listening to a lecture by Jane Thing from Arab. Again, sort of 25 years ago. So, I was a fairly young engineer at that point, and I remember her saying it's completely ridiculous that the more I build, the more I get paid. That's crazy. I'm effectively being paid to do a really bad design. And that was for new build tunnels, I think she was doing at the time. And it's the same thing, isn't it? It's completely ridiculous. We're kind of rewarded for doing really bad designs. We don't, but the only reason we don't is because we're professional. It's, if we just did it on a percentage of construction cost, it's, theoretically, it's in our best interest to do it as badly as possible. So I've no idea though how we get paid for doing very little carbon. I mean, maybe there's I don't know, I've got no idea, but it's got to be the way forward. It's got to be the way forward.
I think it has, and I think I'm glad to be sort of finishing on this sort of thought. And actually, Claire Thomas has also asked a question which really sort of speaks to the kind of professional appointment documents that we have. The schedule of fees, which is sort of based upon new build, and as you say, the fee proportional to the construction cost. We need, as you say, some kind of new paradigm, some kind of new way of thinking, and it's got to be. Well, it's urgent, isn't it? It's got to be the way we go in the future. This low carbon thing, as I say, I mean, the timing of your talk has been so perfect in the context of all the climate conversations that are going on. And I don't know whether everybody who's on the call, I mean, there are still 123 of us on the meeting. We've lost a few, but I would hope that every one of us is engaged in conversations around low carbon and how to minimize it in the work we're doing, in a way that we just weren't 6 months ago, let alone 6 years ago. It's something which we've all very late in the day woken up to, and the profession is having to completely rethink how we do stuff. So, Margaret, I want to say a huge thank you to you for what you have been doing, or for the lecture tonight, of course, but for what you have been doing for many years. The rest of us are just waking up. You're way ahead of most of us, wonderful to be able to award you with the Milne Medal. I think the things that I've written down loads of stuff here, but I think you've inspired us. You've talked to us about all sorts of things that really have opened our eyes to a simpler way of living, which I think we'd all kind of want, really. Hopefully we'll not go to see quite so much in the way of this sort of extravagant, ostentatious new building that we all got rather used to. And a lighter touch to our planet is going to be the way forward. So I would urge all of you to really go home and talk about what you've heard from Margaret tonight, because share it with your friends and colleagues. It's been recorded. It will be just topped and tailed, and then it'll become available online for all of you to see. So Margaret, thank you. And I would of course ask everybody, you sit at home and clap at the cat or whatever you want to do. We're not going to ask you to turn your microphones on and suddenly make a riotous noise, but if we were together in the institution, we would absolutely be making a riotous noise, because Margaret, you have been brilliant and inspired us all. So thank you very much for that and for what you've been doing. And just as a final word, as I say, please do share the recording of this talk once it's available online. But I would also plug another one, because the Institution of Structural Engineers has just recently, very recently, made a film which is on their website. David, are you able to put the link in the chat? If you've got it somewhere near, I'll keep talking for a few seconds.
But I will circulate it to attendees afterwards.
Oh, can you do that? Okay, all right. But otherwise, go to the Institution of Structural Engineers website and find it. It's a talk which is a very short film, which is on the same topic about why all of us need to be completely rethinking, actually, what we're doing and how we do it, so as to give our children and grandchildren some kind of a future. So on that somber note, but hopefully a very sort of uplifting one as well, in a funny sort of way. Thank you, Margaret. Thank you so much for what you've done. Thank you, David, for sharing, and thank you all of you for joining us. A wonderful long list of names. Wonderful to have you all with us from all over the place, I can see. So thank you very much, and have a good evening.